Hey everyone. So, you know how we're just flooded with information all the time? How do we possibly make sense of it all? Well, the answer is statistics. You can think of it as the secret language we use to understand data, to find those hidden patterns, and honestly, to see the world a whole lot more clearly. So, let's dive in and get fluent in the language of data. Here's what we're going to cover. First, we'll ask what statistics even is. Then we'll look at its raw material, data itself. After that, we'll break down the main ways we classify that data. And finally, we'll connect the dots and see why all of this is so critical before you do any kind of analysis. All right, first things first, what exactly is statistics? And hey, let's forget about all the scary formulas for just a minute, because at its heart, it's not really just math. It's more like a powerful method for finding real meaning in the absolute chaos of information that's all around us. I absolutely love this definition because it frames statistics as a complete journey, not just a single step. It's a whole process, right? It starts with grabbing the information and ends with figuring out what it all means. And he calls it an art, which is just the perfect way to think about it. Okay, so this whole process, this art of learning from data, it really breaks down into two major branches. And, getting the difference between these two is absolutely essential. So on one side, you've got descriptive statistics. This is all about describing and summarizing the data that's sitting right in front of you. Think of it as painting a really clear picture of what is. But then on the other side, you have inferential statistics. This is where you use the data you have to make a really smart, educated guess about a much bigger group. This is all about predicting what might be. Let's drill down on descriptive for a second. Its only job is to explore and explain the information you've already collected. So if you figure out the average score for your class of 50 students, you're not guessing about anything. You're just describing your specific class. That's a descriptive study, plain and simple. Inferential statistics. Now, this is where we take a bit of a leap of faith. It's when you take that average score from your 50 students and use it to say something about the average score of all the students in the entire school. See what's happening? You're using a small piece of info to infer something about the whole big picture. And this image just nails that idea perfectly. We can't possibly survey every single person in a country. That's the entire population. It's just too big. So what do? We take a smaller representative group, we call that a sample, and by studying that sample really closely, we can make a pretty strong inference about the entire population. So if statistics is the art, then what's the paint? Well, that would be data. It's the raw material for absolutely everything we do. So let's take a closer look at these building blocks and really get what data is all about. Put simply, data is just facts and figures. It could be numbers, like the marks on a test. It could be the temperature outside. It can even be words, like the comments on this video. It's just information, waiting for us to process it and turn it into something useful. But here's the thing. Data almost never shows up all neat and tidy. A lot of the time, it's messy, unstructured, like a random jumble of social media posts. So to make any sense of it, we have to give it some structure. We have to organize it into something clean, like a spreadsheet. That structure is what unlocks our ability to actually do something with it. And inside that nice structured format, we have two key parts. Each row is what we call a case. That's the who or what we're studying, like a specific student or a specific car. And each column is a variable. That's a characteristic we measure for each case, like their age, their height, or their test score. Okay, so once we have our variables all lined up, the very first thing we do, and this is a big deal, is split them into two fundamental types. This is really the first big decision we make when we look at our data. And here's the cool part. Every single variable you will ever encounter is going to fall into one of these two buckets. It's either categorical or it's numerical. That's it. At the highest level, it's really that simple. So categorical data, sometimes you'll hear it called qualitative data, is all about labels or group membership. It's like sorting things into different boxes. Think about gender, right? It groups people into male or female, or blood type, which puts them into O+ and A- and so on. They're just categories. Numerical data is different. You might hear this called quantitative. This is the stuff we can actually measure with a number, and this is key, do meaningful math with. A student's score, a person's height, their weight. You can add these up, you can find the average, and the result actually means something. Okay, so we've split our data into those two big camps, but guess what? We can get even more precise. There are 4 scales of measurement that kind of act like a rule book, telling us exactly what kind of math and analysis we're allowed to do with our variables. And this little hierarchy here is the perfect way to see it. Think of it like a ladder. We start with the simplest scale on the bottom, and each step we go up adds a new property, giving us more and more power to analyze our data. Let's break them down. Okay, here we go. At the very bottom, you have nominal. These are just names like blood types or jersey numbers. There's no order to them. One step up is ordinal. This adds a meaningful order. Think of a rating. Poor, good, excellent. We know excellent is better than good, but we don't know by exactly how much. Next up is interval. This adds fixed equal distances, so the jump from 10 to 20 degrees Celsius is the exact same as from 20 to 30. But, and this is tricky, there's no true 0. 0 degrees Celsius doesn't mean no heat, so you can't say 20 degrees is twice as hot as 10. And finally, at the top, we have ratio. This has everything, plus a true 0. Things like height, weight, marks. Here, ratios make perfect sense. Someone who is 180 centimeters tall is literally twice as tall as someone who is 90 centimeters. So if you need a quick cheat sheet, this table right here has got your back. It lays it all out. You can see as we move down the list from nominal to ratio, we keep gaining new properties. First order, then a fixed interval, and finally a true 0. And each new property unlocks more powerful things we can do with our data. So we've gone through a lot of definitions, right? We've defined statistics, we've organized our data, we've classified our variables. But what's the big deal? Why go through all this trouble? Why does this foundation really matter? Well, it's because getting this right is the difference between finding real insight and just making noise. I mean, think about it. Trying to calculate the average jersey number on a team is completely meaningless, right? It's just a label. Understanding your data's type and scale is what tells you which tools to use. It makes sure that the story you tell with your data is actually true. So let's just do a super quick recap. Remember, statistics is the art of learning from data. We use descriptive stats to summarize what we have and inferential stats to make educated guesses. We organize our data into cases and variables, and those variables are either categorical or numerical. And finally, those 4 scales, nominal, ordinal, interval, and ratio, are basically the rules of the game that tell us what math we're allowed to do. You see, getting these fundamentals down is what transforms a messy spreadsheet from just a bunch of numbers into a real source of insight. We've basically set the stage and organized our entire toolbox. So now, the really fun question is, with this foundation in place, what incredible stories are just waiting for us to discover inside the data?